Hello and Assalamualaikum everyone. My name is Nur Iman Salia binti Jafri with metric number 200691. Today, my group and I from group 7 would like to share with all of you about wastewater treatment. So, let's get started. We don't like to think about it, but where does last night dinners go once it's flushed down the toilet, right? To think about it, you might already be disgusted, right? Okay, simply considering this topic, it already leads to a substantial portion of wastewater treatment in order to give us a clean water. Wastewater can be classified into domestic sewage, industrial sewage, and storm sewage. But what does it mean? Domestic sewage, also known as sanitary sewage, is transport used water from homes and also flats. While water from the manufacturing or chemical activity is disposed of as industrial sewage. Last but not least is the storm sewage. It's also known as storm water. It is a rainwater collected in a system of pipeline or open channel. All of these sources may contain unthinkable impurities such as blood, insoluble protein, organic acid, oil and fats, color pigment, and also pesticide and herbicide. Each of these pollutants may require different or unique approach to offer us with clean water that we use on a daily basis. Interesting, right? Therefore, today we had like to concentrate on how to clean water that are coming from the heavy metal, pesticide and herbicide, color pigments, and also oils and fats. So stay focused because my friend will share with all of you about this in more detail.
First up, we have heavy metals. Heavy metals are a group of trace elements that include metals and metalloids. They have a relatively high density of over 4 times 10 to the power of 6 mg per liter. There are two main sources of heavy metals contamination, which are number 1, natural, for example, volcanic activities and soil erosion. Number 2, anthropogenic activities such as landfills, agricultural activities, sewage, and industrial pollutants. Examples of heavy metals are cadmium, copper, lead, zinc, and mercury. They are known to be toxic and carcinogenic. According to Table 1, as displayed, it shows the permissible level of heavy metals based on respective regulations. So how can we ensure the concentration of the heavy metals to be below the permissible level? There are many techniques to treat heavy metals in wastewater. Some of them are chemical precipitation, adsorption, membrane filtration, and reverse osmosis. However, adsorption seems to be one of the best suited methods because adsorption techniques are eco-friendly in nature, versatile in terms of having adjustable design and easy to operate, have high efficiency and high removal percentage, can regenerate and reuse the adsorbent for further utilization. It is low cost and has high availability. How does adsorption work? Adsorption occurs because of the interfacial attraction between an adsorbed surface and the molecule being adsorbed. This could happen in two ways. First, physical, whereby the molecule of the adsorbent and adsorbate are attracted via molecular forces caused by van der Waals. Second, chemical, which involves chemical reaction between the adsorbent and the adsorbate. The major adsorbent used for heavy metal containing waste effluent is activated carbon, but the drawbacks of using activated carbon are high cost, complex problem related to adsorbent regeneration, and disposal related issues. Hence, scientists found other low-cost alternatives besides activated carbon, such as coconut shell, rice husk, sawdust, and even egg shells. That is all for heavy metals. Next is about pesticides and herbicides.
Thank you, Auni. So let me introduce myself first. My name is Wan Nur Najibah binti Wan Abdullah. My matrix number is 201898. So today I'll be presenting about pesticide and herbicides. So what is pesticides? Pesticides, which is known as a composite term that includes all chemicals that are used to kill or control pests, is one of the sources of water pollution. In agriculture, this includes herbicides, insecticides, fungicides, nematicides, and also rodenticides. The level of pesticides in water has increased due to improper agricultural practices such as excessive use of pesticides and poor irrigation management. So, selecting a suitable method for pesticides removal is important to ensure the efficiency of the treatment process, and it depends on the type of the pesticide used. The water treatment techniques for pesticide removal can be categorized into three, which are chemical, biological, and physical treatment techniques. So the first treatment for pesticides and herbicides in water is chemical treatment. This treatment involves a variety of chemical reactions that help in hydrolyzing contaminants into safer chemicals. So according to Salimi et al. 2019, the main chemical methods are coagulation and advanced oxidation process, including ozonation and Fenton treatment. Also, chemical treatments are usually used in combination with photocatalysis and or membrane techniques. Advanced oxidation process includes the usage of oxidizing agents which are environmentally friendly to oxidize contaminants and can degrade organic contaminants into harmless products that neither transfer contaminants from one phase to another nor produce massive amounts of sludge. Next, ozonation is the process of using ozone for contaminants removal, either by direct effects of the ozone molecules on the contaminants or indirectly by the oxidation effects of the free radicals resulting from the decomposition of ozone in water. Moving on to Fenton treatments. Fenton treatments involve Fenton's reagents, which are a combination of hydrogen peroxide solution with ferrous ion. This slide shows other examples of chemical treatments of pesticide and herbicides in wastewater. So the first one is chlorination, which is a chemical water treatment method used to put limits on bacterial growth in wastewater, which helps in controlling odor and taste. Second is adsorption, which is a well-known low-cost water purification method that shows very effective results in purifying some of the environmentally and publicly stressful contaminants. And the third one is ion-enhanced sand filters. So that is all for chemical treatments for herbicide and pesticide in wastewater. Moving on to biological treatments. So in biological treatment, various biopurification systems, BPS, were designed to treat pesticide containing wastewater using microorganisms that are capable of digesting pesticides. Biomixtures are usually made of humid-rich substances to increase pesticide retention, soil, and microorganisms. Bacteria present in the biomixture can be of endogenous or exogenous origins. Biological treatment can be divided into two, which are aerobic and anaerobic treatments. Among pesticides, the dichlorinated pesticides are known to be digested by aerobic treatment. The process includes the oxidation and cleavage of the ether bond and the hydrosilation of chlorophenol to form chlorocatechol, and once the aromatic ring is open, the compound can be easily digested by regular bacterial metabolism into water and carbon dioxide. Next, dichlorinated pesticides can also be digested anaerobically by reductive dehalogenation. Once the amount of chlorine atoms is low enough, the compound will be degraded into methane and carbon dioxide. So that is all for biological treatments.
Before moving on to physical treatment, first let me introduce myself. My name is Nur Alia binti Muhammad Hairi and my metric number is 204172. So, for physical treatment, the membrane filtering technique has been widely used in wastewater treatment plants. Filtration can be used at any stage of the water treatment process depending on the membrane type and the contaminants to be removed. The type of filtration also depends on the membrane cut-off size. In this case, nanofiltration membrane with pore size between 10 to the power of -2 and 10 to the power of -3 micrometer are ideal for the removal of bacteria, virus, and large organic molecules.
My name is Nur Alisha binti Muhammad Rafi. My metric number is 204173 and I am going to present the color pigment in wastewater treatment. So, pigment are colorant which are insoluble in water and more solvent. So, color pigment must have a high tinting strength because it is provide visual and stable solid form at ambient temperature. So, there are two types of color pigment which are organic and inorganic. For organic color pigment, it is brighter, purer and richer color, and it is susceptible to ultraviolet radiation, chemical damage and color bleeding. As for inorganic color pigment, it has less brighter, purer and richer color, and it is less susceptible to ultraviolet radiation, chemical damage and color bleeding. Okay, since color pigment are widely used, they produce a huge amount of undesired colored industrial wastewater, which may lead to serious health risks. Therefore, a treatment of color pigment in wastewater is necessary to prevent pollution of water, soil and environment as well as to ensure human health. Okay, so flocculation is one of the methods used to treat dyes and pigment in wastewater. So this method involves the agglomeration of destabilizing particle onto large size particle known as flocks, which then will be removed by sedimentation or flotation. So neutral electrolytes such as sodium chloride and potassium chloride are simply added in a small amount, which are able to reduce the zeta potential of suspended solid particle to zero, and it is sufficient enough to reduce the flocculation of weakly charged color pigment. Okay, the next slide is the alternative method to treat color pigment, which is electrocoagulation. So this method is to replace chemical coagulation by utilizing electrochemical treatment. This process is a low sludge production, simple flock separation, and has less amount of total dissolved solid. So, anode such as iron used will release Fe2+ into the solution through anodic dissolution, and hydroxide will form. The hydroxide form will react with the pollutant present in the water by two mechanisms, which are surface compression and electrostatic attraction. So the advantages of this method, it has minimal sludge, high efficiency and low cost. I think that's all for color pigment treatment in wastewater.
Hi guys, my name is Nur Fatini Afika binti Shukri with metric number 200522. Now I will be sharing on how to treat oils and fat in our wastewater system. So first, what is fats, oil and grease? Fats, oil and grease, FOG, is the type of waste produced commonly at food service establishments or other food preparation facilities. The waste and the byproducts from these establishments can include the sauces, the gravy, the dressings, the deep fried food, cheese, and butter. All these wastes are considered as FOG and can lead to FOG buildup in the sewer system when these wastes are discharged directly into the plumbing system. At wastewater treatment plants, traditional removal of FOG involves the addition of biological additives to break down and consume the grease buildup. This process is known as bioaugmentation, which uses bacteria-forming enzyme to break the bond between glycerol and fatty acids. These elements can next be disposed of by degradation, where the microorganisms are able to feed on the fat, sugar, and the starch waste. There are also newer treatment methods applied to treat FOG, where it focuses on the stimulation of existing bacteria to break down the FOG rather than introducing foreign enzymes and bacteria. This method utilizes the optimized fermentation-based yeast proteins, micronutrients, and specialized surfactant chemistry, dosed at only a few parts per million. This is to stimulate the bacteria population and accelerate natural biodegradation. This new method brings many operational benefits to the wastewater treatment plant, as it can reduce the sludge production, increase the nutrition uptake, and improve settlement.
So, to conclude, wastewater treatment is very crucial in a world with billions of people and even more wastewater. Through wastewater treatments, humans and the environment are both protected from the toxic and harmful compounds such as heavy metals, pesticides and herbicides, color pigments, oils and fats and other compounds which are extremely dangerous and may pose a health risk. As a result, we should be grateful in today's modern technology as they help in purification of water so that we can all enjoy safe and clean water in our daily life.